10-1, day 2. Focus is still on two proportion procedures. But today we turn our attention to confidence intervals. And from this page, the biggest thing I want you to see is really down here in this blue box. We have some new formulas and things look, maybe a little bit different. But notice the structure here that to start, we need a statistic. Back in our one proportion days, that would have just been p hat. Okay, now it's the difference of 2. That's the whole new wrinkle that we've thrown in here. Critical value, literally nothing changes. It's still a z-score. The common ones we would see would be 1.645, 1.96, 2.576. Hopefully those seem a little bit familiar. That's 90, 95, and 99% respectively. And then we see our standard deviation, sometimes called our standard error. That would be right here. It's just a different formula. That would tell you the amount of variability that we would have on our normal curve for measuring the difference of these two proportions as opposed to just one. Okay? Sometimes you see those different formulas and you're like, hey, this really looks different, but you're like, with the way it's structured, not really. Right? Statistic plus or minus critical value times standard error. Universally, that's a confidence interval. And it doesn't change with working with two samples. Quick review on some conditions. Random, normal, and there's independence, right? Independence is always there. We never do it, but that's all right. You can read through it if you're interested. Even though I just scribbled it out, you could probably still read it. We got to verify that both samples are random and that the normal condition is met for both. Here's the data, and a good one. We've done some other political ones before, but this is a good one to do just because you can see the added element that you get from two proportions is not only could we measure an approval rating, we now could compare two of them to kind of see how is that approval rating potentially changed over time. It's one of the many things that two sample procedures allow us to do that we couldn't do before. Just to kind of get organized here, here's what the data said. Obama's approval rating in 2009 from a sample of 1,010 was that. Took a separate SRS in 2010. We got 512 out of 1,024. That's exactly 0.5. Okay, so we see it looks like over that year a 3% drop. The interval will kind of help us out with, was that drop just due to sampling variability? In other words, what we have always just called random chance. That's, those are the type of samples that we got. Or is it enough to say that we'd be convinced that it actually went down? You could go in either order, but notice I went 2010 minus 2009. So I got to stick with that order the whole time. Okay? Same state step as always. Right? I said that we're going to construct a 90% confidence interval for P sub 2010 minus P sub 2009. You could use different subscripts there if you wanted to. And then I define both of those parameters. P sub 2010 is the true proportion of U.S. adults who approved Obama's job performance in September of 2010. And then for 2009, it's basically the same, except it's from September of 2009. For random, we have two simple random samples. We'll call them US adults. Normal, let's see here. For the first one, we had 535 that said yes, they approve of the job performance. 474 said no. $512 and $512, there it ends up being the same because it's 50-50. All those are way bigger than 10, so a normal approximation is good to go. Here's my interval. That's coming from 0.5 minus 0.53. Right? Remember my order. 2010 minus 2009. There's my critical value for 90% confidence. Whoops. That didn't go there. That would just be p hat sub 2010, which I do not want there. What I do want is 0.5 times 0.5. And here's 2009. Gonna make one other little adjustment here. There we go. That's all set up as it should be. The test you'd be looking for in the calculator would be a 2 proportion Z interval, right? In the plan step, we always name the procedure. That's what you're looking for in the calculator. And you would get this. We're 90% confident that interval captures the true change in proportion of U.S. adults who approve Obama's job performance from August 2009 to August of 2010. Okay. There was a follow-up question here that I kind of skipped over. Is there convincing evidence that the job approval rating has changed? No, there's not. Right? You'll get really accustomed to this with 2 samples or 2 proportion procedures. You're almost always looking to see a 0 in the interval, and here it is, right? And sometimes it's tempting to get into like, oh, it just barely got in there, but it's in there, right? So it is plausible that the true change in approval rating is 0. Okay, so we would not say from this that we're convinced that it's gone down. All right, so look through the context on this one. I simplified it a little bit because you might look at it and be like, really? Those numbers just seem weird. I didn't want the parameters to get too wordy. So what it said, that what they're measuring is going online for work or school every day. Okay, so that number seems lower for students, but what they're saying is, basically think going to Schoology. Do you go on Schoology every single day? Right? From the sample, 63% of students said yes that they do, and 37% said no. Almost 2/3, 1/3. For adults, 68 said they yes for for work-related purpose, and 32 said no. Okay? First things first, define my parameters. I just said P1 is the true proportion of teens that go online every day. Notice that's just an easier way to say it. I didn't want to say the true proportion of teens that go online every day for school-related purposes, yada yada, right? Go online every day. P2 for adults. I want to estimate P1 minus P2 at the 90% confidence level. So let's go ahead and do that. For random, I would say of n equals 800 and an SRS of 2,253 adults. It's not ideal for the sample sizes to be that different. It's okay, and you can like continue the procedure. It doesn't make it invalid. You'll see, and it's kind of common sense, we'd prefer these two samples to be relatively similar in size. Like the presidential poll that we just did, that's a little bit more ideal for the size. All right, now for normal. Breakdown for teens was 504 and 269. Adults was 1532 and 721. And I just verify that, yes, indeed, those are all easily over 10. Now those, so like the 504, it didn't say it specifically, but I'm like 800 times 0.63, right? For the 296, 800 times 0.37, okay? There you had to actually go and do a little math to get them. There's my statistic, negative 0.05, right? Because that's 0.63 minus 0.68, plus or minus same critical value because I'm sticking with 90% confidence. Chose to mix it up a little bit here. You know, we love 95, but never bad to use a different confidence level. Here's our teens. They were 0.63 over 800. The adults were 0.68 times 0.32 over 2253, which would give us this, negative 0.0824 and negative 0.0176. Okay? There you see our conclusion. Notice that both endpoints are negative, which with the way we ordered it, that means that adults are going online for work at a higher rate. Okay? What the interval would tell us, though, is we think not, I mean, that's number one, because it's all negative. Not only are adults going online at a higher rate, we think it's somewhere between 1.7 and 8.2% higher than it is for teens.